Hello everyone, welcome back to another tutorial. This tutorial I would like to explain all primitive data type in Java and use cases and advantage disadvantage of this primitive type. So let's get started a Java project. I'm opening VS Code. Here we will create our first project. Since I have been saying from the beginning we should create a file with such a name, that name we should provide inside the class name. For our case, we will create main.java. .java is extension, is very necessary to provide same spelling. Our IDE is too smart. It already creates the structure, but its create interface we would change it to class. We have to mention here the public method. Our IDE help to write the public method, public static void main, and that takes a string array arguments. We'll discuss more about it, these arguments, but for now we have to recap our fundamental architecture of computer again. When user press power button, our system is not automatically start up. Our system have to go through a several process to make it operable. In very beginning, our systems start to load firmware from ROM to our main memory. Then the processor will definitely understand where the operating system is located inside the hard drive. Then our processor start loading operating systems from hard drive to main memory. Not all the functions and files from the operating system, but the basic and kernel files from the operating system's path. In this concept is similar in here in Java programming. When we have created a large project, we may have many classes and many methods. But our Java is not run over the operating system or hardware, it's run over the Java runtime environment. And our Java runtime environment not run any method or any classes from our extremely large project, but it's run only the main method and its related classes. And our main method might call another method and vice versa, another method call nested method, and go on and on and on. And that's how Java programming works. So this is the brief explanation of the main method. Now I'd like to move on to primitive data types. Java provides 8 primitive data types. We will see one by one. Java provides 8 primitive data types, which are byte, short, int, long, float, double, char, boolean. Here 6 types are representing number, which is byte, short, int, long, float, and double. And last 2 also it represent number, but in specific rules. For example, char represent characters and boolean represent true or false binary state. We'll see these 2 more detail, but today we will focus mostly on the number type primitive data type. So if all 6 represent number, why we need 6? The answer is for better memory optimizations and better performance. When we need a small number, then we would define byte. For example, byte number equal to 100 and byte number 2 equal to 10. If our number is less than 127 to minus 128, we will define bytes. It takes extremely less memory, around 8 bit, and this is 1 byte, and this is more memory efficient. we can print out. We are adding both numbers together, and we can run our project by Java C. We are saying the Java compiler to compile the main.java class, and our compiler is compile the classes, and it's giving the bytecode, and we can run this code Java main, and this is the answer 110. This byte primitive data types can hold up to 8 bit. So why I am saying it can hold up to 127 values in terms of decimal, why not 255? Here is the tricks. We can assign directly number, and we can assign directly the binary. We will assign binary, and I will explain how it's working behind. It's hold up to 8 bits, so we will provide 8 bits number, 0 0 0 0 4 bits, and then 4 bits, and we can run it. It is equivalent to 1. Here is the number which fill up with 0 0 and last is 1. In binary it's 1, and in decimal it should also 1. And we are getting 1. But if I change a little bit here, if I change first 4 as a 1, it will provide us 15. The binary 4 1 means in decimal it is 15. Yeah, that's the answer we are getting here. But the very first postfix bits, the first bits is not representing any number. If I provide 1 here, what we will get? This is not representing any number. So what it's representing? If we compile this file, we are getting error. Our first bit is representing the notion, either it's positive, either it's negative. So if we keep it like this, and if we fill up all three with the 1, we will get 127. So let's see the all type of arithmetic operations in bytes. In bytes, if we have B1 is 10 and byte B2 is 3, we can run all mathematical operation here, like addition, byte sum of B1 and B2 is B1 plus B2. And we can run a command java c main java and java main. It will give sum of B1 and B2 is 13. If we multiply B1 and B2, it will provide 30. It's providing 30. And the difference of B1 B2 is 7. and divided b1 b2 is string. So this all we expecting. So what will be the remainder or modulus? What will be remainder or modulus? We just use percentage and that will give the remainder or modulus. That will be 1, I think. Yeah, 1. This is how computer work internally. So if it's working everything like that, why we need short? If our number is more bigger, then bytes cannot hold all the numbers, then we need short. Short provide a bigger memory capacity. It's double than bytes. Short will fit for larger number than the bytes. So why need integer? When short is handle a specific range 32,768, but integer can handle more than the bytes, and long can handle 64 bit. It's far more larger number than ints. And float is for fractional number, which come with some fractions, not completely integer. And double also provide the larger fractional number where float is not suitable. So that's for today. We are closing this video here, and next session we will talk about char, boolean and some logical expression. Thank you everyone.